right, guys, welcome to another episode of IoT Happy Hour. I'm David, developer advocate here at Balena, and I'm joined today by some faces that we don't see too often and one face that we see all the time. I'll start with the face we see all the time. Chris, you want to say hello?
Hello, yeah, I'm Chris, hardware hacker at Balena. Yeah, happy to be here and watch David destroy a balenaFin today.
Yeah, I was going to cover
well, hopefully
that,
not destroy.
No, we're not going to destroy it. John, you want to go next?
Sure, I'm John. I'm a technical marketing lead here at Balena. Looking forward to seeing this Sense application on the fin with some outdoor sunniness there in David's hometown.
Yeah. And Mark, you want to say hello to the audience?
Hello, this is Mark, developer advocate at Balena, working with David to create healthy developer community. I'm looking forward to see your roof, actually, and desert of Arizona.
Yeah, it's not that exciting, to be perfectly honest, but we'll take a look at it. So yeah, as the guys alluded to, today's episode, we are going to deploy a balenaFin, which is a Raspberry Pi carrier board that we produce, onto my roof, which we're going to later use as a LoRa gateway. For now, though, we're just going to run balenaSense on it, which is a ready-made application. We're going to use a senseHAT to grab temperature, and I think Chris' pressure sensor is working on it now as well, if I remember correctly.
Pressure sensor is now working. Yeah, for the longest time, the pressure sensor wasn't supported on the senseHAT in balenaSense, but now it is working. Happy to report.
Yeah, awesome. Very cool. So I'm going to start off with the live build. Then I'm going to, hopefully, if all goes according to plans, transition to outside and climb up, get on the roof. I've simplified the install. I did some testing yesterday, did nearly fall off and die. So I've simplified it down. I think we're going to be fine today.
Like, what do we do in the case that happens?
Well, you take over the show.
We need some way to.
we have a technical difficulties screen.
Do I need to dial 9-1 and then I can?
No, that won't work. You're in the UK, so we'll have to have John do it. But we'll be fine. I got it all figured out. So I do want to open up though with a chance to give folks an opportunity to get joined up. I see a few folks have already popped into chat as well. I usually like to start off with what new toys are on your desk. Chris, I know that you always have the best desk there is, but
I feel a bit lacking this week.
No, that's okay, because I was going to one-up you this week. I have, yep.
Nike shot on your table.
No,
right.
I don't know if senseHAT is on this.
Oh, there is one around here somewhere.
Yeah, he's got that, but I've got a new toy from 96 boards. Can you see that? Let me check.
What's that?
This is, let me get a little closer, an Avenger 96. So if senseHAT were on the stream, he would be able to talk more about it, but let's unbox it. Live unboxing. Here we go. This is a STM32 part that runs on here. So we don't currently have any STM32 support in Balena OS. So this will be a fun challenge to see if I can get Balena OS running on it. But like all 96 boards devices, it's got the standard layout, standard configuration. This is one of the extended ones, which happens to have Ethernet on it as well. But yeah, and the SoC is on the back. So I've got some weekend hacking in front of me. I really need a new hobby.
So what's the retail on one of those?
$129 US. So not super expensive, but certainly more than your typical Raspberry Pi. But more enterprise grade. It's got 8 gigs of eMMC on it as well. which we'll talk about when we switch over to the Fin. But
well, that's always good, because I think people overlook the fact when you buy a Pi, you need to buy a decent SD card as well, which is going to be at least another $20-30 for a good one.
Yeah, exactly. And I mean, we certainly see on a regular basis SD cards failing around here. The cheap ones just are not reliable and don't last. So yeah, eMMC on it is a nice bonus. So with that said, that was my desk. You guys get anything good?
Yeah, as I say, I'm pretty light. I do have another version of my Inky Shop project. Like, I had a blue one last week, and now I have a black one. But the blue one's somewhere else.
That's all right.
But yeah, I remember David last week. He said he was going to build one. The other David, that is David in chat. He said he was going to build one. So I'm interested to know if he managed it.
Is that?
I shot JR.
Is that chargeable, or does it? Do you have like a single AA battery inside, or what?
No, it's just USB powered. So if you unplug it, it goes offline. But of course, it's an e-paper display, so it'll retain the image.
That's cool.
But yeah, the write-up is soon to come, and we've got a video coming for this channel as well.
Awesome. Yeah, I'm looking forward to it. I'm going to order the parts in and build one myself as well. And I think if I remember correctly from last week, the case you had there is 3D printed, and the schematics the STL is in the GitHub repo, or linked from the GitHub repo.
That is right. I will put the link to the GitHub repo in the chat.
Yeah. And David is saying, didn't get to it, but it's on the list.
Oh, yeah.
Caught up. Oh, he was watching Maker Faire. Okay, well, that's valid. Last week, for those who missed it, we presented 4 topics at the virtual Maker Faire meetup. That was all related to COVID type projects. So we had submitted our thermal scanner Pi project, Alan's LED alerter that everyone likes to hit the buzzer on. Obviously, Fold for COVID, which is the protein folding on the Raspberry Pi. And then what was the 4th one? Oh, that was Phil's video calling on a Raspberry Pi project. And those talks all went really well. So you can catch those on our YouTube channel under Virtual Maker Faire. You'll see them there.
I ordered a camera with USB camera with built-in audio like 2.5 weeks ago, still in transit. So everything else is perfectly set up and ready to go based on Phil's project, and which didn't take very long, but I can't test it for real and ship it to my mom.
Awesome. And Mark, you got anything on your desk? I thought I saw some rack parts laying around. Yeah, hang on, you're on mute.
Yeah, I play a bit with the balenaFin, trying to get the coprocessor playing with the compute module. So I will keep you updated with that. On the other hand, there is a Raspberry Pi with 8 GB of RAM coming to my home.
Oh, you ordered
the new one?
Yeah, the new one. And as well a LoRa hat for my Raspberry Pi or balenaFin to play a bit with LoRa, the Things Network, or maybe Helium. Let's see.
Mm-hmm. Very cool. Yeah, see, my plan there is, so I'm going to do this Fin build. We'll get started in a minute. But, I've got Mark doing all the hard work first. And then after he gets it all running, then, yeah, it'd be simple. I'll just follow his footsteps. Perfect plan.
Well, actually, this is what we do with Chris, no? He does
yeah, I mean, we pretty much do that with Chris on every project. Yeah, we make him do all the hard work, and then we just get to show it off. Yeah. All right. So as I mentioned, I'm going to do what might result in some hardware failure death by putting a balenaFin on my roof. Now, for those who don't know, I live in Phoenix, Arizona, and it is just a little before June. I expect that this thing will be all right for a short period of time, but it's going to get very, very hot here. Being in the US, I'm accustomed to Fahrenheit. So we'll hit about 120 degrees typically as our peak. I've seen it go a little higher. I've been here for 30 something years now. Once I put the fin inside of a case though, on top of a roof.
That's 49 Celsius.
That's 49 Celsius, yeah.
Not bad.
But I'm going to put this thing in an enclosed plastic box with a clear top. I'm in direct sunlight. So I'm not entirely sure how hot it's going to get inside the box. So that's going to be part of the fun. We're going to take some bets on what happens. The fin is rated up to 70 degrees Celsius. So I'm not entirely sure if we'll hit that once it's in the enclosure or not, but we're going to find out. So he's saying it's 93 there at 9 a.m. Yeah, I hope I don't pass out while I'm on the ladder. All right, so let's see here. The thing I wanted to ask though is, what have you guys killed? What, quote unquote, possible hardware related deaths have you experienced? Chris, I know you must have killed some hardware in the past.
I haven't killed too much that I can think of. Like I know a couple of Pis have suffered from accidentally shorting out GPIO pins or applying too much voltage and stuff like that. But I'm sure there's stuff that I've blown up. Plenty of capacitors have suffered. I remember once I was building a plasma speaker, where you get the high voltage arc and modulate the sound onto the arc so it comes from it. And I had these capacitors in a bank on a breadboard, and they just were rated for nothing even close to the requirements, and they would just sort of randomly explode and eject their contents all over the desk. So, but I didn't have any others, so I just kept replacing them and they kept exploding, but I just put like a shield there.
John, Mark, any hardware death you wanna fess up to?
Yeah, like Chris, I I baked a Pi by doing some continuity testing live on GPIO pins, because I kept turning it off and doing some testing because I had a little LCD screen on it and it wasn't working, and I was like, oh, I'm just gonna test it live. I'm like, oops, dead.
Let's see. David says he had an Arduino go on fire through a leg punctured a connected LiPo. Yeah, that'll do it.
Yeah, those batteries can get violent.
Yeah, I've seen some of those videos. Those lithium batteries are dangerous.
I mean, those videos just make me want to try it.
Well,
I need to find some batteries and put a nail through them and see what happens.
Not recommended by Balena.
No, not endorsed. Tomas says he pulled the HDMI port off of a Pi Zero. That's we'll count that, but that's not the kind of death I was thinking. In fact, I wonder if it's even still functional, just no video output. Let's see. Mark, have you killed anything?
Yeah, I burned some Arduinos actually in the past, doing some interactive shows like 5-6 years ago. So it was fun, and not fun because they were inside a sofa. So yeah, it was tricky.
Wait, now you got to explain why you had them on a sofa.
Yeah, hold on. The Arduinos were inside of a couch, a sofa?
Exactly,
what is
a
that all
couch.
about? Yeah. What is that all about?
So we were, some friends in Munich, Germany, and we were hacking on a project. And actually, there was a advanced music festival in Barcelona called Sonar. I don't know if you know that, but it's all about advanced techno music. And we made a project that it was a sofa. Actually, we connected the master table of music of the main stage of the Sonar. And actually, we were getting that music and converting that music into analog signals and sending through the internet to an Arduino. Actually, that was moving some motors and some servos that were on the sofa. So the sofa actually was moving at the vibe of the music that was live on the main stage. So you could feel the music. Actually, in Catalan, there is this verb sentir, that means listen, but as well means feel. So you could feel the music. You couldn't listen to the music actually, but you could feel the music in real time. And it was a really cool project that we made with some friends. I think it was 2012, that project.
Yeah, it sounds like we're going to need to duplicate this build. Do you recall how to do it? I think there's a future episode right there.
It was called One Seat Away. I think it
sounds like a ride at an amusement park or a theme park. Get on it, it starts moving.
Actually, presenting that in San Francisco, yeah, some people was really excited to put that in Coachella.
I can imagine. Wow. All right. Well, we'll have to check that out. I think, even if it's just the like what it takes to build it. I don't know if we could somehow get a couch onto the episode or not. I don't know if we can expense that, but even just the steps to replicate it. So awesome. All right. Well, let's get going on this fin. Let me switch my camera over, and I'm going to do a quick.
Are you going to have audio, David, during your?
During what? During the actual once we head out onto the roof?
Mm-hmm.
We absolutely should, assuming everything goes according to plans. But first, I just wanted to show off the balenaFin for anyone who's not familiar with it. Chris, I've got my blurry camera on. So you'll be excited to see I'm using my blurry camera again today. So I got all my parts ready. I'm going to cover the fin really quickly, just for the sake of time. We do have some other documentation out there about the fin, and even we'll do some devoted video content to it from a board bring up in the near future. A couple of weeks back, we had the guys on from the Fin team. We had Carlo and Nico join us for an episode. So if you go back in the YouTube IoT Happy Hour playlist, boy, was it episode 4 or 5? I can't remember off the top of my head, but you can find a detailed session on the Fin. So I'm just going to be pretty quick about it today, but essentially, it's a Raspberry Pi compute module carrier board. So most people are familiar with a Raspberry Pi that looks more like this form factor, whether it's a Pi 2, a Pi 3, a Pi 4, whatever. But the Foundation also produces this SOM, system on a module, which has just the processor, the RAM, and you can get them with or without onboard eMMC. Which again is handy in the case of IoT applications so that you don't suffer from SD card corruption or death. So the Fin then is the carrier board that exposes all of the ports and functionality provided by the SoC on the compute module. So we have standard stuff like HDMI, GPIO, which we're going to be making use of, USB, Ethernet, and the camera connectors. Although in the case of the Fin, you actually, on a version 1.1 that I have here, you have 2 camera connectors, as opposed to a normal Pi, which has just 1. It does have some additional features though, like SIM card slot for your cellular modems, battery on it for an RTC, and a Cortex M4 MCU, so microcontroller that allows you to turn off the rest of the board, turn off the main processor, which is something Mark was talking about exploring earlier. So anyways, with all that said, I'm going to deploy one of our projects called balenaSense to this thing. So first things first, I want to go over the rest of what I have in front of me for the purposes of a rooftop installation. So balenaSense is going to make use of a senseHAT. And as mentioned, standard 40-pin GPIO. I can pop the senseHAT right on to the Fin. That's easy enough. Now we've got our temperature, pressure, and what's the third one? Humidity on the senseHAT. I've also got 16 feet of 5.5/2.1 millimeter power cabling, so I can run power up to the roof. The Fin does not get powered by a standard micro USB port like a normal Raspberry Pi does. It actually gets powered over a more reliable, a little bit stronger 5.5 2.1 millimeter barrel jack. So I'll need some cabling to get up there. I've got a couple of heat sinks. I'm not so sure that these are going to make a difference. What do you think, Chris? You think a heat sink is really going to save the pin at this
I don't know
point?
about save it. It might slow down the death.
You think? I don't know. So should we try? I mean, I can.
Yeah.
I've got some thermal tape already on it. I don't. Or we could let the audience vote.
I mean, the air outside is going to be what, 40 Celsius, so it is still a little bit cooler.
Yeah. For now.
David in chat wants to know what the 90s PDA looking thing is on your
Now,
desk there.
that's very important. It's very important to make that call out. I also have with me a wireless meat thermometer. Now I'm going to use this because I'm going to stick this into the concrete tiles that are on my roof, and let's power this thing on. Okay. Now, well done beef. I need to get to 170 degrees Fahrenheit. You can't really see if I get the angle just right, but this is my meat thermometer. Okay, now let's see what chicken cooks at. Hold on a minute. No. Well done hamburger at 160. Oh, we'll hit that easily, no problem. So we're definitely going to need that. Got our cabling. I've also got an IP67 box that will put the fin in. Now, yeah, I made the mistake of getting the clear top one. I'm wondering if we should actually just install it upside down to keep the direct sunlight off of it. Or maybe
but then you can see if it's melting, actually.
Do we want to see if it's melting? Maybe we don't want to know. I'm not entirely sure. So
I think you should, to avoid turning it into a greenhouse, you should probably mount it upside down.
Think? Do like that? Put it upside down? Yeah, I don't know. We're going to find out when we get up on the ladder. So I think we've got everything covered from the parts perspective. I drilled a 3/8 inch hole into the bottom side, which technically defeats the purpose of IP67, but it's a firm fit for the plug. There's really no, I'll go back later and kind of seal this off with a little bit of epoxy or some resin or something. I'm not entirely sure, but it'll be just enough to, I can't go any further. The plug is just a little greater than 3/8 of an inch. So pretty firm. So I'll have a little bit of
You could maybe
cleanup.
get some of those rubber cable grommets as well to seal that up.
Yeah. And if I do this, there's the pitch, there's the angle of the roof. So this will be on the bottom coming from the downstairs. So if gravity does its job, any water should roll off and down the cable, but I'll clean that up a little bit later. So, all right, so let's get our 90s PDA out of the way for the moment. And
I wanted a PDA so bad in the 90s. I wanted one of those Palm Pilot, which I can't remember which one it was, but they were so cool. But I could never afford one on my pocket money as a kid.
Have you gone back and looked on eBay? Maybe there's some.
Yeah, I could probably get one now. They don't have the same appeal now, really.
Now's your chance.
I have
Store all my phone numbers.
I have a couple in a drawer,
including
a Palm Pilot phone.
Ooh, look at that.
It
was the Scion one with it had like an unfolding, it had like a little keyboard, and
it had a stylus and a color screen.
Oh dang! Well, that's
that's the Cadillac of the PDAs. Wow. Okay, so now I'm going to attempt to do a screen share. I'm not sure that my laptop is going to be able to keep up, but we're going to give it a try. Let's see here. Share. Desktop. Share. And let me know if you all can see this. Might take a moment.
Looks good.
Looks
yeah,
good.
We see your Etcher and the
okay,
balenaCloud
we've got
dashboard.
Etcher and a balenaCloud. All right, great. So What I'm going to do to deploy balenaSense to this device is, first things first, log in. That's a given. All right. Chris, if you don't mind, would you, now I've lost my other view. Can you grab this URL to the blog post for balenaSense and drop it into the YouTube chat so folks can
Cool.
can follow along? But the first thing I need to do is actually a Git clone of the repo. So Chris, if you don't mind dropping the repo in as well, the URL to that, I need to grab the code. It's all pre-written, ready to go, thanks to Chris's hard work, Chris and the team, I should say. So let's come over to this tab here and copy that.
Yeah, both those links are in the YouTube chat now for anyone that wants to follow along.
Thank you. What do I need to do? Git clone that balenaSense repo. And that's pretty quick. I should now have a balenaSense directory. I sure do. Let's make sure it's got some stuff in it. Yep, looks like it's got some Grafana, Influx, and Telegraph containers. All right. I've already gotten the Balena CLI installed, so I have at my disposal Balena set of commands. And I am going to come over here and create an application in balenaCloud. Rooftop fin. That looks good. Choose a device type. Choose a balenaFin. I'll leave it on microservices for now is fine, and create an application. So give that a moment. And we have a new application created. Now it says that we don't have any devices yet. How about adding one? Well, that's a good idea. Let's add a device. It's already pre-populated with the fin. And I'm going to leave, actually, I'll put it in development just in case we need to do any SSHing to this thing later. And I'm going to go Wi-Fi plus Ethernet. And I created a temporary SSID and password because I know Phil's probably watching and is going to be jotting down my Wi-Fi credentials to hack my network later. So let's grab those.
Next time he's in Phoenix.
Yeah, I'm sure. So, SE, drop in the phrase. Oh, good, it didn't even expose it. I figured he was ready with his pencil and paper, but so we look good here. We are going to download the OS. So this will come down. So now we're pulling down a ready-made image to be flashed to the fin. Take a moment there and get Etcher ready. And I'm going to switch my camera back if I can figure out how to the fin one last time. And the reason is this. I didn't cover this earlier, but right here we have a micro USB port on the fin. And I said earlier that we don't actually power the device over micro USB. So why is that there? The reason that's there is the fin has eMMC on it, like we talked about. And that is how you flash the device. Oh, and we've got the hat already on. Ooh, good thing I was not looking directly at that. When you power up a senseHAT, it gets extremely bright. Okay, now, in a moment, what we should have is Etcher recognizing the fact that I've now attached the fin and its eMMC, and it'll get mounted as a block device, just like a USB stick or an SD card. And sure enough, yep, Etcher now shows compute module 7.82 gigs. Okay, so I can select the image that I just downloaded. What did I call it? Rooftop fin, I think. Downloads. balenaCloud, rooftop fin. Select it and start flashing. All right, so we are now flashing the eMMC on the fin. Chris, have you ever tried flashing with hats on the board? Is this going to interfere with it at all, do you think?
I haven't, but it shouldn't as long as we're not drawing too much power.
Yeah, I don't think we are. It's flashing away.
Yeah,
if this
looks fine to me.
Fails, we may have to detach the senseHAT for now. I didn't think about that, but looks like we're underway. While that's going, let me check chat. Have we had any questions roll in?
No, I think we're pretty good.
Pretty good over there. All right, excellent. A couple of comments about a PDA museum. I shot JR. There you go. Modern and a Scion, both as daily drivers. Ooh, nice. Okay, so that's now validating. And if all goes according to plans there, we should see, oh, wait a minute. No, still going? Okay, thought I saw a pause for a second. Let's come back to here.
So David, is there a reason why you chose to use the DC power for the fin instead of a power over Ethernet feed up to your roof?
Yes, the reason is because I don't have a close power over Ethernet upstream device. My router is downstairs. My switch is downstairs at the front of the house, and I am going to place this at the back of the house on the roof. I just didn't have the ability to cable it. My wife would have killed me if I tried to run that amount of cabling all throughout the house in order to then go outside and up and over. It just is not feasible. But you're right in making a call out that I did not mention. Power over Ethernet is an option here on the fin as well. So that's actually a very common use case when people go install fins. I just didn't have capability for it. All right, so flash is complete. Let's pull the plug.
Do you have experience with the Phoenix jack?
Using power in the Phoenix jack, you mean? On
yeah,
the fin?
Exactly.
Yeah. I think the one that I've got outside is power over Ethernet, and I took the power straight off the pins on the board and fed it straight back into the Phoenix jack.
Cool.
Because it comes, when you buy one, it comes with the little Phoenix terminal connector, so you can wire in your own wires and plug it in. It's quite handy.
Yeah, Phoenix power adapter is not something I have used. I think it's more in the industrial scenarios and use cases. But yeah, that is another option for powering the board. All right, now it's probably tough to see because of the senseHAT, but I do have some LEDs flashing on the side of the board. So I think I've got some activity here. Hopefully we should see this show up in just a moment. Checking the clock to see what our time is. Yep, okay, here comes Divine Frost. Nice. And this is running the factory build, but it is online. It's powering up. It's checking for any containers. And we don't have any containers yet. but we're about ready to push some. Balena push. What did I call it? Rooftop fin, if I remember correctly. Uh-oh, system program detected. Oh boy. All right, looks like we're okay here. Let's give it a shot. Oh, update available. I haven't used this VM in a little while. So what we're doing right now is I had already done the Git clone earlier, as you saw. The Balena push command is bundling up that directory and pushing it up to the balenaCloud builders. Those are big machines in the cloud that take the essentially Docker recipes, build the containers there, and then push them down to the connected device. So looks like we are moving along. The builder has started. It's going through running the steps in the Docker file in the compose. And what are we on? 4 out of 17. All right, that might take a moment, but at the end of the process, what it'll do is then bundle it all up, and the device, actually I can change my camera back to me at this point. Let's do that. The device will then check in, realize it has a new workload available, and download those containers. Okay, working on which one? Grafana at the moment. Okay. Uploading images.
So is it worth a quick mention for the new deploy to Balena button?
So it is worth a mention there. This project, when I checked it the other day, I didn't see a deploy to Balena button. Have you gotten one on this blog article now that I missed?
There is one on the GitHub repo if you scroll down, but not on the blog article. I don't think.
Aha. Okay, so we'll have to update the blog article. That's what I had checked first, was the blog article. Now, yeah. So what Chris is mentioning here is that I went through the steps. I mean, you watched me go through the steps. They're not terribly difficult, but yeah, you still need to have some expertise, right? I mean, you need to know how to use the CLI. You need to do a Git clone. You need to then go through this manual step of the Balena push. Uh-oh, not deploying release. Are we going to have some difficulty?
Live debugging.
Uh-oh, live debugging. The BME 680 returned a non-zero built-on ARM. Uh-oh. Some services failed to build sensor. Service sensor.
That's just saying it failed to clone that repo.
Yeah, does that repo not exist? Did you move a repo recently?
Maybe, David, it's time to use the deploy to Balena button and try it for a second time.
That would essentially use the same recipe, though.
It would, yeah.
So where I was going, though, with that for the deploy to Balena button is as simple as that. We've now abstracted those steps out of the process, and the deploy to Balena button is just a web button that hits the API and performs the same set of commands, all automated in the background. So it will essentially prompt you, you click the button, it prompts you to create an application, or you can choose an application if you already have one, and the device, and it will automate all of this for you. So that methodology is really convenient for new users, for folks that just kind of, don't have the command line experience. And it looks like it found it this time. Inflating BSEC. Oh wait, maybe not.
Yeah, it looks good this time.
Yeah, it looks good this time. All right, we'll chalk it up to internet hiccup. So yeah, for folks that maybe are still a bit scared by this process that I'm showing, the deploy to Balena button is far easier. Okay, and this user isn't logged in. Can you talk to GitHub? Yeah, just checking the YouTube comments. But hopefully this works.
Yes, the other cool thing about using deploy to Balena is that you can, like, you would have been able to hit the button and you could have had the build going then downloaded your image in the background. So it could have been like, it saves a bit of time, I think.
Yeah, that's true. And especially I'm looking at the clock. I'm probably going to be pressed for time here, but.
Nah, we got plenty of time. We'll get this thing going.
Yeah. All right. So while that's going, I guess what I could do, well, no, I don't want to turn it off now. I have it powered up and grabbing the containers. I was going to say I could put it into the box, but that's only a 3-second procedure anyway, so no problem there. All right. We've got a unicorn. Nice. So once we see Charlie, we know that the build was successful. And coming back over here to balenaCloud, the supervisor running on the device, running on the fin, has checked in and realized, hey, a new build has been essentially, I mean, for lack of a better word, I'll call it published in this case, but a new build has been created. I need to be updated. So it's checking in and downloading those containers that were just built by the build server. So we are pulling them down now. I see we have Grafana, InfluxDB, MQTT, Sensor, and Telegraph. Chris, can you give me a little quick overview on what those are? What are these pieces I'm actually downloading at the moment?
Sure. So the whole idea behind balenaSense is so you've got a nice local dashboard with some pretty graphs and gauges on, so you can see the readings from either the senseHAT or there's a couple of other sensors like the BME 680. The idea being it's like a simple air quality monitoring project. So if we start from the top and run down the list, Grafana is your pretty front end. So that's a cool tool that lets you visualize all different types of data. InfluxDB is the time series database that's actually holding the data. So every 10 seconds, I think, we're taking a measurement from all those sensors that you've got connected and storing those within InfluxDB. I'll come back to MQTT. Okay. Sensor is a Python application. So we've got a small bit of Python code, and that's what's actually taking the readings from these sensors. So every time we add a new sensor to the project, we go in and we add a little bit of extra Python code just to interface with those particular sensors. So there's like, there's a bit of Python for the senseHAT, a bit of Python for the BME 680, and we had a cool contribution from the community to add reading from one-wire temperature sensors as well. So there's a little bit of Python for that. Sensor just brings all those different libraries that we need to access the different sensors into one place. So then we can use Telegraph, which is the final thing. And so Telegraph is the thing that every 10 seconds it has a process running. So every 10 seconds it will ask Sensor for the current values of all those devices, and then it will insert them into InfluxDB. And so that's just a process that's constantly running. And it actually uses HTTP requests in the background. So Sensor offers an HTTP interface to Telegraph, which then polls it, takes the readings, puts them into InfluxDB. And so finally, MQTT enables you to take your balenaSense sensor readings and send them off to another place. So one example, Alan, one of the other hardware hackers, built this, built a Home Assistant project, and he was able to set up balenaSense and use the MQTT provider as an input to Home Assistant. So he's got his balenaSense sensors showing up within Home Assistant. So yeah, I think that's a rundown. We're looking at developing balenaSense a bit more for like a version 2 to turn it into a maybe I know we're still sort of thinking about it, maybe like a citizen science project where everyone can crowdsource their air quality data.
That'd be pretty neat.
It'd be interesting to get
Now,
readings from all these devices and bring them into one place so you could compare.
now, would you have to, so hang on a minute though. Knowing, of course, that the project is in GitHub, it's open source, folks are going to have all different types of hardware on hand. So would you have to then go back, like you said, add a little bit of code, a little bit of snippet to the, which container was it? It was actually the sensor container, right? Or
Yeah.
folks gonna, I guess, be encouraged to use the existing hardware, or how would that work?
I think what we'll try and do is have like a recommended set of hardware. So
Okay.
like the BME 680 is a good start, but then you could add like a small particulate matter sensor as well. That's quite cool. And I know Sean on our team he's got like a fully like pimped out balenaSense with like CO2 sensors, particulate monitoring, and he's got the Enviro Plus hat from Pimoroni, which has got like lights, light sensor, color, and I think maybe UV as well. His Grafana dashboard's got loads more charts than I've got.
Oh wow.
Yeah,
so
I did something like that. I took initially a DHT11 and then a bunch of one-wire sensors, and then eventually data from the Ecobee API stream for my home thermostat, which provides not only all the data from its remote sensors, but outdoor data, temperature, storm information, things like that, and used the InfluxDB in this project to collect all that data and show it in a single dashboard. So this project is pretty flexible that way. You know, with a little bit of tweaking, you can feed a lot of different kinds of data into it.
Yeah, that's a really good point. It's very easy to bend to your whim.
Yeah, and InfluxDB, if you're not familiar with that, you know, takes simple key value pairs. And this project really makes it easy to send that data and create those, or essentially JSON streams, to parse it, and then Grafana does the rest.
Yep.
Okay, so I see some activity here. I think we may be up and running.
Looks good to me.
Looks good. Now I'm going to do this little toggle switch right here, which is going to enable a public device URL. And what that is going to do is then expose the device.
Does it have a buzzer?
It does not have a buzzer. And oh, I need to get this out of here. Oh boy, you guys are going to copy and paste this URL, and yep, nah, no buzzer. Oh boy. All right, here we go. We're online. So I will actually put it in so folks can hit it for themselves.
Yeah.
Not a
This
problem.
is reading the sensors data every 10 seconds, Chris?
Yep. So as David's got the senseHAT there, so
right,
you see we're giving a reading for indoor air quality. Now on the senseHAT, the senseHAT doesn't actually have a sensor for that. The BME 680 does, but so in the case of the senseHAT, we're sort of coming up with like a guesstimate of indoor air quality based on the temperature and the humidity.
Gotcha. All right. So, I mean, all things considered, I didn't write a line of code. I did do the Balena push, but all of these containers were ready-made. All I did was assemble some hardware and plug it in. Pretty cool. So now it looks like it's working. If I unplug it, I'm going to, let's do this actually. Let's do a graceful shutdown, and we're going to go put this thing on the roof.
Now, David, I noticed that the pressure says it's stormy, which it's clearly not in your area. Is there a way to adjust the elevation within the device variables to?
That's a good.
I don't know if Chris, if you know something about that, because I know with my weather sensor, I always have to calibrate it to my elevation to get the barometric pressure information correct?
Yeah, so there's a environment variable called balenaSense _ altitude, and you need to set that as your height above sea level in meters, and it will adjust the pressure reading accordingly.
Fantastic.
Interesting. So I need to figure out what my altitude is then, because I do not know off the top of my head. I think somewhere between 1,000 and 2,000 foot. Okay, so we're powered down. Let's get this out of the way now. Bring the box over. I really don't know about this heat sink. I'm just not so sure about this. But let's get it in here. How are we looking on time? Ooh, 7 minutes. Uh-oh, we might run over for this episode.
It says, according to the Googles, Phoenix is 1,086 feet or 331 meters above sea level.
Say again, I'm sorry.
So according to the Googles, Phoenix is 1,086 feet or 331 meters above sea level.
1,086. Yeah, that sounds about right. Okay. Screws in.
Closely followed by a question, someone asking, why is Phoenix so hot?
It is a desert. You ever heard of Death Valley in California?
Yeah, I went to Death Valley last year.
You went to Death Valley?
Mm-hmm.
And you didn't die?
No, it was quite hot though.
Yeah?
Even at 6 in the morning.
Yeah, it's similar. If
Actually, I think air conditioning was invented in Phoenix. That's right.
Yeah, I think so, actually. All right, so looks like we're good. We're closed up. All right, so I'm going to have to leave you guys for a moment to talk amongst yourselves. I hope you can come up with some banter. I'm going to stop screen share, and then I'm going to turn off that, go to...
I'm just worried about how we're going to come up with some banter.
Yeah, you're going to have to come up with some banter. So I'm about to head outside. I'm going to rejoin from my phone. And if everything goes according to plan, we should be able to do the rooftop portion. So you guys have fun for about 30 seconds. I'm going to run. I'll go as fast as I can and head outside. All right, back in a bit.
I think when he gets back, Chris, we should have him enter your 331 meters.
Yeah, for sure. Like I want to see how, because that's a very low pressure reading. I want to see how much it brings it up.
Yeah, because what do you say? It's about 1,000 feet.
Yeah,
it's not minor. Definitely has an impact.
Yeah, I'm down at, I think, 13 meters. I don't know what that is in feet. But yeah, it's not very high above sea level at all, so it has virtually no impact. So it's quite cool because in the code, it's no matter what sensor you use for pressure, it applies the altitude adjustment at the very end. So in theory, you can plug in any pressure sensor and it will still use the same variable to adjust the altitude.
Nice.
I'm still Googling why Phoenix is so hot.
And the thing,
see how hot it actually is.
With Grafana, it'll show obviously the difference, right? So when you're looking at the graph of the pressure before the adjustment and then the pressure after the adjustment, it'll show the elevation and be able to track from there.
Yeah, I guess we should be able to see like a step change in the reading.
Right.
Do you think it will survive the fin? What do you think?
You know, if David survives that ladder, oh, he's coming back.
He's got a step ladder on a balcony, hasn't he? Trying to get onto the roof.
Yeah, it's like a tile, like a terracotta tile roof, which are common in the desert.
Yeah.
Which can be pretty slick. So I don't know how far up the roof he was going to place it. And if he had, I think he had a piece of wire or something that was going to hold it in place. Maybe he can explain that.
Right.
Oh, here we go.
Okay.
It's stormy.
Beautiful.
Yeah, David, we need to apply that pressure adjustment because it doesn't look very stormy there.
Look at all that green grass.
Grass is common in the desert, isn't it?
Not that kind of grass.
Oh, okay, there's the step ladder. Like,
we should have some music, no?
Yeah, we need the Balena theme song.
David, I don't know if you're talking, but you're muted.
Maybe we can go to the chat.
That's better.
Yep. Sorry about that. Apologies. Okay. So you can see here, we're going to have a little bit of problem, though, with glare. I think we're going to have an issue in seeing once we get up there. So let's start off with, I'm going to get us plugged in. Later, I'm going to clean all this up, weatherproof all this. I need a bigger electric box. But for right now, we'll leave the wiring out. Let's also get this untied. Should have done that in advance. Apologies.
I mean, this is good. This is live action fin installation.
Oh yeah, this is an absolute live install. So I will get I'll get all the wiring. Okay, we've got power. It's alive. Okay, it's coming online. I see some LEDs over here as well. All right, it is alive. Yeah, so what I'll do is I'll run the cabling up the side here. I'll weatherproof this connection with some, I don't know, I guess some waterproof, maybe like electrical tape or something. And I guess we're probably ready to head up, huh? Let me get my meat thermometer in my pocket.
Just in case there's a meat emergency at the top of the list.
In case there's a meat emergency. Well,
there might be some steamed hams to measure.
Exactly.
I mean, you can imagine that it is very easy to cook on these concrete tiles that you're about to see. So let's take a trip up the ladder. Let's get this fin.
On the chat, people say flip-flops on a ladder. Is
Oh,
it safe enough in
what's wrong with that? Yeah. Well, it's still in the shade. Couldn't do it later. Okay, here we go. My flip-flop just got stuck. My flip-flop is stuck.
If you're following along on the Grafana dashboard, you can see already in the last 30 minutes that the temperature is changing.
Is it?
Oh, yeah.
Yeah, Grafana is live. Yeah.
Right. You had it in the shade initially. I'll be interested as like now.
Some interesting spurious humidity readings there.
Yeah.
Humidity? There's no humidity.
It's saying you've got 212% humidity.
And it's very unhealthy to live here, maybe.
Must be your huffing and puffing right into the box.
All right. So now what I wanted to do for again, temporary purposes so that it doesn't fall off the roof in the next day or two, because I'm going to need some way to drill into the concrete, into the tiles, and I don't know exactly how I'm going to go about that yet. So for the time being, yesterday I put some string up here, and this string will hold it in place for the next day or two. So
I shot JR in chat is saying it's picking up your fear, David.
Oh, is the fear sensor on? I didn't know the fear sensor was on. Okay.
Is that fear of the ladder or fear of his wife?
A fear of the wife. Correct. All right. So I don't think I'm going to be able to tie one-handed. I may have to come back up here after. Tie it. But it shouldn't go anywhere, at least for till tomorrow. I'll have to run to the hardware store tomorrow and get some sort of a permanent fixture for it. But we are in full Arizona sun at the moment. This thing should start cooking.
Okay, we're currently running at 34 Celsius, but 170% humidity.
Well, I can assure you that there is zero humidity in the air. It is as dry as could be, especially up here.
I wonder if we've hit the senseHAT's limits on dryness and it's like looped all the way back around.
All right. Now, let me turn off this. I'm going to run back inside. So you're going to need another minute or so of banter.
Actually, the temperature is decreasing.
Decreasing?
Now it's 33 degrees. But actually inside, when you turn it on first time, it was 34 degrees.
I mean, is the senseHAT broken? All right. Okay, let me shut down. It's up there. And let me run back inside. You guys talk amongst yourselves for a moment, and I will be right back.
Yeah, I'm definitely concerned about the legitimacy of these readings from that senseHAT.
Yeah. I wonder if a service didn't come up properly.
I imagine all the services are fine. Otherwise, it wouldn't actually be taking readings. It's just, yeah, that humidity is a bit dodgy.
Well, the good part is that you can push the new code and solve the bugs, no, without going again up to the ladder.
Exactly.
Right.
Unless it's actually a hardware fault, in which case he does have to go up the ladder. Not much we can do to fix hardware remotely.
Yeah, it's always tricky to work with air quality sensors and temperature sensors because, yeah, the calibration, it's always tricky. And, well, maybe temperature and humidity, it's simple.
I ran. I'm out of breath. Okay.
But with other air quality that have chemical components, it's always tricky.
All right.
Yeah.
To work
with them. I'm out of breath. Hold on. Switch camera back and made it. Okay. By the way, it's warm out there.
I mean, it doesn't look that warm. It's only telling us it's 33 Celsius.
Okay. So now
33 degrees Celsius in the UK. Where do you live, Chris?
What is going on? Why is the temperature dropping?
Do you think it's so? What did you do with your PD8 thermometer? Did you try it?
Oh, I think I left it on the roof.
Maybe you should check. Maybe it's 32 or something.
Oh no.
Although it'd be good to update the altitude offset as well, just so we can see that, see if it gets a bit more close to what the actual value is.
Device variables, add variable. What is the name of it?
It is balenaSense _altitude.
All caps?
All caps.
balenaSense _altitude.
Yep.
And what did you say I was at? 1,000, roughly?
I'd say, oh, it wants it in meters, so I'd put in 311.
311. Oh, oops, yeah. Screen share's back off. We're over on time. It's all right. So share screen. Back to the desktop. Share, just like we had previously. Okay. So what I did, what I'll do, let's copy that real quick. So over here in the cloud dashboard, oops, went back too far, sorry. Hey, our device has been online for 7 minutes up there. It's still alive. Okay, device variables is what I'm going to do. I'm going to click add variable. And Chris, you said it was balenaSense _ altitude, and Phoenix is 311.
Right. Looks good.
We'll add that.
So on Grafana, we should see a step change in the pressure variable, or the pressure reading rather.
We are going to reboot when we do, well, at least restart the containers, right? Yeah, I see them.
Yeah, so we'll restart the containers to apply the new variable.
Yeah, so we made a change in the cloud dashboard. The device is now told by the supervisor, via the VPN, is told, hey, something has changed. Please go update yourself. And so it automatically cycles the containers with the new information. Let me pull the logs back down.
So this is deleting the data in InfluxDB, actually?
No, it shouldn't do.
Okay.
Data persistent? Why do I have 169% humidity? It is clearly not raining out there. You saw the desert.
I think we will need a section every new IoT happy hour about how's the balenaSense on the fin on David's roof.
Yeah, check in on it.
A new section, David's roof.
Oh boy. All right. Well, I'm not convinced that my senseHAT is functioning properly.
No, it does not look very healthy. It looks very unhealthy, in fact. It's even telling you that.
Yeah, it's literally saying that it is very unhealthy. Wow, incredible. All right, well, I don't know that I can trust our data, but you saw the build, you saw the installation, so it's up and running. I guess we'll have to troubleshoot what's going on with the actual data coming off of it, but
yeah.
All right.
And well, it's 10 a.m. At what time should we expect the peak of temperature, David, on the Grafana, so people can just
well, in its current location, probably about 3 p.m. local time.
So in 5 hours.
And it's a little after 10 a.m. local time right now. So another 5 hours.
So it was in the shade right now, was it?
No, it's in the sun. My house faces east-west. So at a certain point, the sun is high enough that it's crossed the apex of the roof line. It is in sun. It's just not in, perpendicular 90-degree sunlight.
But yeah, that's I've never seen a senseHAT give a humidity reading that high.
Yeah,
so
maybe my senseHAT's failing. I wonder if I should order in a new senseHAT.
We might need to sort you out with some better hardware, and then we can revisit next week.
Yeah, possibly. The senseHAT, Phil, the senseHAT is a random number generator.
I mean, it totally is.
I could have just installed a random number generator on the roof. All right. Well, what do we think? Any other questions? I missed some of the chat through here. Oh, people were taking bets on my survival. What is this? What are the odds of heat failure or David of the board? Yeah. All right. No questions to be addressed, though, I don't believe.
So Google says that now in Phoenix, it's 37 degrees Celsius.
37 at the moment. That sounds.
So it could be 33. Why not?
And in those measurements are in the shade. This should be.
Yeah, we should be
above
much.
that.
We should be much higher than that. Well, I guess we'll troubleshoot what's wrong with the data coming off of it, but it's up there. I will. Yeah, I see. Actually, command strip adhesive. It could actually do that. It's really not going to go anywhere. I don't know if I don't really want to drill into the concrete roof tiles, so maybe I will find some other way of just fixing it, but it's not going to go anywhere. So, all right, any other questions? I don't see anything in chat. If anyone has any questions, go ahead and drop them in. We'll get them answered. And then...
I mean, people can save this device link that we shared, can't they? And then they can monitor it throughout the week. And then hopefully if we get you some better hardware, they'll see some more legitimate readings.
Yeah. But I mean, the fundamental process, we did demonstrate it. It's up there.
Absolutely.
The senseHAT was just something I wanted to add for the time being. Later, what I want to do after Mark does all of the hard work is actually add a LoRa module to that device and then broadcast as a LoRa gateway from up there, because it's pretty high up. That was my balcony, as you could see, because I showed the drop down. So that was the second floor, and then I could move it further up the roof. I left it there just for video purposes, obviously. I didn't want to actually climb all the way up to the apex of the roof, but maybe later I'll try to move it a little bit further. I'll see how much cord I have left. I think I'll have pretty good LoRa broadcast range from up there. So, that'll be a future episode there. We'll add LoRa to it.
Cool.
Let's make it happen.
Yeah. All right, you guys. Well, I'm gonna close it out here. Hit any last questions in there? Nope. Does the data always get cleared on reboot? Question from Gary. No, Chris, I believe we have persistent data on this, right?
The InfluxDB is stored on a persistent volume, but it does look like something's gone wrong with your device there, because it did. Like when we updated that environment variable, it looks like it's cleared the data. Like that's not normal behavior for this project.
Yeah, well, I think we can verify my senseHAT is not the best. So, all right. Well, no worries. I think we have gotten...
I think Phil was asking about the CPU temperature there, wasn't he?
Oh, I want to know what the CPU temp is. What is that? Can we grab that?
You can run that command from a terminal. Like that's the one.
Which one?
Phil's put one.
Let's see here. VCgen CMD measure temp. All right, copy that. Come back over to balenaCloud. We can SSH directly to the device across the VPN. Paste the command. Ooh, not found. So it's not included in the base OS then.
So you can use, I've just put a command in chat there as well. The cat sysclass thermal one.
All right, copy that. And bring it over to here. 70,000 degrees. It's hotter than the temperature of the sun.
It's like milli-Celsius or something. So that will translate to 70.9 Celsius, which is pretty toasty.
Yeah, it's pretty toasty. Well, I mean, I added a heat sink. What more do they want?
So that's the limit, right? It's 70 degrees. The
yeah. Yeah, I wonder if it's going to go into thermal shutdown. I mean, are we there already? Like literally it lasted 10 minutes up there?
Well, that will be the CPU temperature, not necessarily the temperature in the case. So it should be all right for a while longer.
All right. Well, we'll keep watch on it and see what happens. So, all right, you guys. I think we are good to close it out. Thank you, everybody, for joining. Thank you, everybody, for watching.
Thanks, David, for risking your life.
Yeah, no, the flip flops probably wasn't the best idea, but oh well. All right, you guys have a great weekend, and we will catch you next week.
Catch you later.
Bye, everybody. Bye, guys.
Bye.
Bye.